Hi, this is Rick for EDU Mobile. We're going to talk a lot about the new Swift language throughout the iOS8 course, but I thought I would give you a little primer on the Swift language before we actually started the course. This is one thing that we can do that doesn't actually break the NDA with Apple. Now, if you do have a developer account, you should go ahead and download Xcode 6, and it comes bundled with iOS 8. And that way you can open up a new playground and try some of these concepts for yourself. By the way, the Swift interpreted environment is called a playground, and we can test out concepts and work through some examples in a playground without having to subclass a class and go through all of that overhead. We can just try Swift out in a playground and test out some concepts. Now, I have a series of playgrounds in this tutorial, and the first one here is EDU Mobile 1. So this is a file of type .playground. So let's go ahead and start. And I wanted to start first of all with the concept of variables and constants in Swift. We use variables only for values that will change or are likely to change within the run of our application, and we use constants for everything else. So the way we declare a variable is with the keyword var here, and the way we declare a constant is with the keyword let. So we've set up a couple of things here. We've got a variable called version, and we've just set that equal to 7. Now Swift will implicitly get the type of a variable or constant from context. So the type of version is an integer, and in Swift that's capital INT is the type, and the type of the OS variable, or the constant, I'm sorry, is a string. So at this point, let's just try some tests here. We should be able to say version equals 8, and Swift says, yes, that's okay. I can set version equal to 8. Let's try setting OS equal to, I don't know, OS X. And Swift complains about that. It says here, cannot assign to let value OS. What it's saying here is I can't change the value of a constant, and that makes sense. Now, if we want to see more detail about that, we could open up the timeline window, and we can do that by selecting this view here, and that gives us the history of this value, and we have a console output here: playground execution failed, error, cannot assign to let value OS OXX. So we can actually read in the console output a detail about our errors. All right. Now, if we do want to get rid of this or want to not see this, we can open up the toolbar, and then we can go out of the assistant editor because the timeline is shown in the assistant editor. So we can get out of that view and go back to our playground view this way, or we can open up that view by looking at both the playground area, the main editor, and the assistant editor. Okay, so pretty cool so far. So this doesn't work. Let's get rid of this statement altogether. Now, we can also make a string out of the operating system version and the version number. So let's go ahead and do that. We can say var full version, let's say, is equal to, and then we can say that we want to print out the OS, and that's a string. And so it interpolates the full version variable as a string variable. And then we can just add up pieces of strings this way. And then if we want the version, and we can see it happening over here as we do it, if we want the version to come out, we need to cast it as a string, and then version. We need to add that. Sorry about that. And now we'll see this come across as iOS space 8, which is what we wanted. Now, we've already talked about implicit typing, let's talk about explicit typing. So let's say that we define a variable. Let's call this amount, for instance. And we want it to be a floating point variable, or a double actually. If we just assign this something like 3.5, then the type of amount here is a double. We can explicitly say that this is a float, not a double, by doing this. And now the type of amount is a float. We could try saying that it's an int, and let's see what happens there. And now we get an error, and we should, because it's interpolating this as a float, or actually a double, and then trying to assign it to an integer type, and it can't do that. So, of course, if we just did this, that would be a double. Okay. But let's go ahead and explicitly assign it as a floating point value. All right. And the only reason we would do this is because we didn't want it to be a double. When Swift sees a number like 3.5, a real number with a decimal point, it interpolates that, or it implicitly assigns it a type of double, not float. So if we want it to be a float, we need to tell it, I want this to be a float. And then we can perform floating point operations on it. We could say var new amount equals amount plus 7, and that would of course give us back 10.5, but new amount now is typed as a float because amount is a float and we've just added an integer to it. So there is type conversion going on in Swift, but because of variable implicit variable declarations, we usually don't need to do this. A double is just fine. So if we got rid of the float, then new amount would be a double because amount would be a double. All right, so now let's do something else. Let's say that I just want to see what the value of amount would be if I cast it as an integer. The way we can do that in the playground environment is we can just say, give me the integer value of amount. And we can do that this way, int amount. And that is going to give us 3. We'll see that in a moment. So we can convert types. We can say, actually, double. If I could type, that would be great. Double amount. And that is going to convert amount, which was a float, into a double. Now it doesn't look any different, but there it is. Okay, so let's look a little bit closer at strings. First of all, what is a string? A string is a sequence of characters. So there is a type in Objective-C called character. So let's set up a string, and actually we have one. We have full version here. We could say something like for character in full version. So we have a for each loop, or a for in loop, if you want to call it that. And let's just go ahead and say var c equals character. Now, what are we really doing here? Well, first of all, it's telling us the for loop is executing 5 times, but it's not telling us what each character is. First of all, in the for character in full version, we don't have to tell the type of character because it's assumed that since a full version is a string, and a string is a sequence of characters, it's going to be implied by Swift that character is of type character. So now when we assign the variable c to character, the type interpolation is getting done and c ends up being a character. If we look at this, if we examine this in our timeline window, we see that character here gets assigned sequentially I, O, S, space, and 8. And that's exactly what we would expect it to be. Okay. So a string is a sequence of characters. Now, of course, we know that we can assign full version like this and say OS plus an empty space string plus a string cast of our version, which is an integer. And by the way, string and then in parentheses, this is a constructor of the string class, and this takes whatever it is given. It's overloaded for different types. It takes whatever it's given here and interprets it as a string and returns that string. So we can, of course, do this. We can build our full version string by adding up components of a string, but there's actually a niftier way to do that. We can use what's called string interpolation to build a string, and let's go ahead and do that. So now we already have a string full version. Let's build it in a different way. Full version is equal to, and now we're just going to build this inside of a string. If we use the backslash parentheses syntax, we can say OS and then space and then backslash parentheses version. And what this does is it takes whatever we give it inside the backslash and parentheses and interprets it as a string and places it in that position in the string. So now I have full version is equal to iOS8. Now, there's a couple of things that I've kind of implied here but haven't really gone into. We have the for loop. This is a for each loop. Of course, we also have a for loop as the C for loop, where we give it the initial, the condition, and the increment. And we'll show you that in the next one when we talk about control structures. Thank you very much.